The computer mouse is one of the most successful interface objects ever created, largely because it disappears while being used. It sits under the hand, responds instantly, and rarely demands conscious thought. When it works well, it feels less like a tool and more like an extension of intention. That invisibility is not accidental. To understand why the mouse exists in its current form, it's necessary to look at what interacting with computers used to require. Early computers were not designed for exploration. They were designed for precision. Input came through keyboards, punch cards, switches, and typed commands. Every action had to be planned before it was executed. This made computers powerful, but intimidating. If you didn't know the right command, nothing happened. If you mistyped, you failed. Interaction was brittle. Errors were costly, both emotionally and practically. You had to think in advance, often in abstract terms, about what you wanted the machine to do. This created a barrier between humans and machines. The mouse emerged as an attempt to reduce that barrier, not by making computers smarter, but by making interaction more human. Instead of symbolic instructions, it offered spatial movement. Instead of naming actions, it allowed pointing. Instead of committing immediately, it allowed hovering. This shift cannot be overstated. The mouse turns interaction into exploration. You can move without consequence. You can see possibilities before choosing. You can back away. This reduces cognitive load. It also reduces fear. People are more willing to try things when mistakes feel reversible. The mouse's design reflects this philosophy at every level. Its form is deliberately simple: one primary movement, one or two buttons, optional scrolling. Anything more would increase mental effort. The goal is not to impress, but to vanish. The mouse also maps physical movement to abstract space. A flat surface becomes a window into a digital world. This mapping is not literal. Moving a mouse 1 inch does not move the cursor 1 inch. Acceleration, scaling, and smoothing are applied. This is an important trade-off. The mouse sacrifices physical accuracy for perceptual comfort. It is tuned to feel right, not to be right. That tuning allows large screens to be navigated with small movements. It allows fine control without strain. It adapts to different users without explanation. Again, the design favors human perception over technical purity. The mouse also introduced a separation between navigation and action. Movement is continuous. Clicking is discrete. This allows users to think with their hands before committing with their fingers. That separation creates safety. You can hover over a file without opening it. You can move toward a button without pressing it. You can change your mind. This sounds minor, but it fundamentally changes how people approach systems. It encourages curiosity. Before the mouse, interaction was often all or nothing. After the mouse, it became incremental. This is the mouse's quiet aha moment. It doesn't make computers easier by simplifying tasks. It makes them easier by making failure less punishing. Design constraints reinforce this approach. The mouse had to work for long periods without fatigue. It had to fit many hand sizes. It had to operate without visual attention. It had to be cheap enough to include with every machine. This explains why its shape converged quickly. Curved enough to rest the hand. Weighted enough to feel stable. Symmetrical enough to accommodate left and right-handed users, or at least not exclude them entirely. Even as technology improved, optical sensors, wireless communication, touch surfaces, the core interaction remained unchanged. Move, point, click. Other interfaces have tried to replace the mouse. Touchscreens remove mediation entirely. Trackpads compress the surface. Voice interfaces remove physical input. Each has strengths. None fully replaces what the mouse does best. Because the mouse is not about speed or novelty, it is about control without pressure. It allows users to act at their own pace. It does not rush. It does not demand attention. It waits. That waiting matters. The mouse respects hesitation. It allows uncertainty. It creates a buffer between thought and action. Over time, this changed who could use computers. Graphic designers, writers, children, casual users, people who didn't think of themselves as technical. The mouse lowered the cost of entry by making interaction feel physical rather than procedural. As graphical interfaces evolved, the mouse became less visible, but more essential. Menus, windows, icons, all assume pointing. The mouse is built into the logic of modern software even when it isn't physically present. Trackpads emulate it. Touch interfaces mimic its logic. Even virtual reality controllers echo its principles. Movement first, commitment second. Once you see this, the mouse stops feeling like a peripheral and starts feeling like a philosophy. It embodies a belief that humans should explore systems safely before being asked to decide. That belief is invisible, but it shapes how people learn, work, and create every day. The most influential designs are not the ones that shout innovation. They are the ones that quietly rearrange behavior by making the right thing feel easy and the wrong thing feel reversible. The computer mouse does exactly that. And because it does, it disappears, leaving only the illusion that interacting with machines was always this natural.